And, we've done a bunch of these. I think this is the eighth one we've done in 2023. And we haven't been in person yet. The weather has just been cloudy this year. And so doing these virtual ones once each month, I try to make them a little different each time. So we're not just repeating a lot of the same things. The stars do change from month to month a little bit. And over time, if you looked at, go on YouTube and find one of the ones we did last spring, the stars are very different in the spring than they are in the fall, but they're not that much different in October than they were in September. So what we're going to do is approach it a little differently. And we're going to begin where we often begin, is with the sun above the horizon. Now, the sun doesn't move, but the earth orbits around the sun. So what that means is, if you could see the stars behind the sun, because remember, there are stars up in the daytime, the sun would always be in a constellation. And as we move around the sun will appear to travel through a series of constellations. Those are the constellations of the zodiac. The path the sun appears to travel is called the ecliptic, and it's this line right here. And it moves eastward, which is to the left, this way through the stars. Now, people think that the sun moves to the west. If we speed up time, it's going to drop to the west, but that's not our motion around the sun. That's the earth rotating or spinning on its axis, making day and night. As we go around the sun each night, if you came back tomorrow and looked at the sun at exactly the same time, the sun would be sitting right about here. The next day it would be right about here. And then the next day here. And it travels eastward along the ecliptic, which is the path of the sun. Now, if you could see the stars behind the sun, you would find it's in a constellation. You can't do that outdoors. You can't shut off the glare of the sun and see the stars. But the handy thing with a little program like this is I can shut off this glare and see the sun against the stars. And look at that. There's our sun against all the stars in the background. And the sun is always in a constellation. And right now it's in the constellation of Virgo, the maiden. Now, to see Virgo, and I like to start with this because we're going to kind of follow this ecliptic this evening. We're going to stay right along the path of the sun and go through the entire night from sunset, which we're pretty close to right now, till the sun comes up tomorrow morning. So we're up for the whole night right now. We're going to do it in an hour. But let's start with the constellation the sun is in. And the easiest way to see that is just to remove the sun out of the picture for a minute. And I'm going to take the ecliptic down, though we're going to bring that back because that's our path we're going to follow. This time of year, Virgo is kind of lying with her head down and her feet up in the air. And the way I draw Virgo, we always find the bright star Spica, which is the brightest star in Virgo right here. I'm going to dim the stars down a little bit because it's easier to see the constellations. So here is Spica, and Spica is supposed to be a sheaf of wheat, and she's holding it in her hand. So this is her sheaf of wheat, a whole bunch of wheat, in other words, in her hand, and her arm comes up here, and this is her shoulder with her head here. Remember, she's kind of upside down. Come back up to her shoulder, and her other arm comes up here. Come back to her shoulder, and she's got a stick body. She's just a stick person. Come here, and then she's got a leg right there and another leg right there. And I think it makes a pretty good stick person. Earlier in the summer, she's more upright, but right now she's kind of diving down below the horizon, and she'll disappear soon. She's actually disappeared now because the sun's up there. So let's, the way they draw Virgo is a little different than the way I draw it. They draw it like this, and I think she looks like a clumsy lady this way. So think of this the way I do it. This is her sheaf of wheat in her hand. Her arm comes up like this. This is her head, and I ignore this part. This is her other arm, and I ignore this line and draw this line for a body, then a leg here and a leg there. Now, you might say, how are you supposed to draw this? It doesn't really matter as long as you use the right stars. You see, officially speaking, Virgo is everything inside this red polygon. And as far as astronomers are concerned, you can connect the dots any way you want, as long as you use the stars inside this polygon. So those are the stars of Virgo right there. And that is where the sun is. And if we bring the sun back up in the sky, you can see it's right there within the boundaries of Virgo. And the sun's going to follow this path of the ecliptic over the course of the next year. And a year from now, it'll be right back in the same spot. We're going to follow the ecliptic across the sky and leave the sun behind. So let's let the sun go down. We're going to let it drop down. and I'm going to leave the glare of the sun out of the picture here. We could bring it back up and all those stars would disappear, but we're just going to let it go down and leave the stars up behind it and follow the sun as it moves the path of the sun across the sky and see where it would go in the course of the year. Now you notice the sun's not following along that line. The whole line is dipping down as the stars dip down, because that's the Earth rotating right now. And since we're past the equinox, the first day of fall, it's going to set to the left or the south of west, as you can see it's setting right now. Now, just as the sun sets, there is one planet that's just above the horizon as the sun goes down. And we'll stop it as soon as the sun gets below the horizon, right there. And just to the east of the setting sun is this orange star. Well, that's not a star. That is the planet Mars. Mars is right beside the sun in the sky right now. So up close, Mars kind of looks like a little red dot. And it's red because this planet is rusty. So the rust is in the soil, it's in the rocks, and rust has a reddish orange color. And with a telescope, you can see that reddish orange color. And it's been visible all summer long. Right now, with where it is next to the sun, you're not going to see it actually. It's there in the sky right after the sun goes down. But remember, this is not what the sky looks like after the sun goes down. The sky after the sun goes down is going to look like this. And the sun's gone, but the sky's still awash with its light. So Mars is right there, but obviously you can't quite see it, even though it's in the sky. We're going to find all the planets tonight because the planets go along the ecliptic. The ecliptic is the plane in which all the planets go around the sun, including the Earth. They might be a little above it or below it, but they never get very far from it. So we know that the sun is in Virgo. After Virgo, as the sun moves eastward, the next constellation to come to will be Libra, the scales. So let's let it get a little darker so we can see the stars here. We'll let it drop down, get rid of Mars, and we're going to stop right about there. Stars are starting to come out, still a little bit of glow there in the sky. And Libra is simply a square. It's everything inside that polygon, but the way we draw it is these two stars are the bar, because remember, Libra is a set of scales, and it's the kind with the pans that you weight up and down, put weight in one side and something in the other. So this is the bar across, and then there's a pan down here, and another pan down to a star that's just below the horizon right here. We can draw the lines in there for Libra if you like, something like that. It's just a box, not the most exciting constellation. So that's our second zodiac constellation. After Libra, what we think of as the next zodiac constellation is Scorpius the Scorpion, correct? Well, the Scorpion's right here. It's visible from late July till September, and then you can still see it in October, obviously, because you can see it tonight, but you can't see all of it. The Scorpion's tail curls down below the horizon right now, then comes back up with a stinger right here. So to see the Scorpion, look for the bright star Antares, which is a reddish star. And it's often referred to as the heart of the scorpion, because it's about where you imagine the scorpion's heart would be. And the name Antares actually means the false Mars, because Mars, remember, we saw it. I showed it to you here, though you won't see it outside tonight, even though it's in the evening sky, because it's in the glare of the sun. But when it is in the sky, it has the same color red as Antares. And since Mars follows the ecliptic, and the ecliptic is just above Antares, once every couple of years, Mars becomes really close to Antares, and you get the real Mars next to the fake Mars. People see that red star and they often confuse it with Mars. That's how it got its name. Now, the Scorpion, I want you to see the whole thing, and something we can do here, which we can't do on Quill Hill, is we can make the ground disappear. And we get rid of the ground, and let's bring up all the stars like we really are somewhere in the Rangeley area where you don't have all that light pollution, and you can see the Scorpion very well. Here's Antares, the heart, the head here, and the claw here, and a claw there. Come down the body, and the tail curls around and comes up with the bright star Shula for a stinger at the tip of the tail. I think it makes a pretty good Scorpion in the sky. Let's bring the ground back, though, because I don't want you to leave you floating in space. You can see that tail just dips below the horizon. You could see the whole thing back in August, but right now it's dropping down low in the sky. Now, in ancient times, they drew this a little differently, because Libra was actually part of the Scorpion. This star right here in ancient times was considered the Scorpion's the tip of its claw. It's a star with a really cool name. It's called Zubin Shmali. Cool name, huh? The only one with a cooler name is the other claw, which they made come up to this star, Zubin Janubi. And those two names are from ancient Arabic. Zubin Shmali means the northern claw, and Zubin Janubi means the southern claw. Today, they're not even part of the scorpion. Something else kind of interesting here is we think about the zodiac. Let's bring up our boundaries here. And we go from Virgo, where the sun is now, to Libra, to Scorpius. And then the next one, if you follow your horoscope, it would be Sagittarius. Well, Sagittarius is right over here. And we look at the boundaries of it, and we see it's a very large constellation. But if you look at the sun's path, it doesn't go from Libra to Scorpius to Sagittarius. It goes through something else right in here. That's another constellation called Ophiuchus. And the sun is actually in Ophiuchus longer than it's in Scorpius. The sun enters Scorpius on November 23rd, right here, and it leaves Scorpius on November 30th. It's only there for 7 days. Then it enters Ophiuchus, and it's in Ophiuchus for the next 19 days. So that's the unknown zodiac constellation for people who follow horoscopes. If you're born between November 30th and December 18th, astronomically speaking, you are an Ophiuchian. I don't know how you tell your horoscope with that. Well, let's zip on through to the next famous zodiac constellation. That's Sagittarius the Centaur right here. And Sagittarius is supposed to be a centaur, and a centaur is half man, half horse. And as if that's not complicated enough, he's supposed to be shooting a bow and arrow. So let's just look at Sagittarius here and forget the other ones for a second. I'm going to light it back up here. Just Sagittarius. There it is. And can you make that into half man, half horse, shooting a bow and arrow? Something like this, I suppose. I don't know how they get that picture from those lines, but that's how it's sometimes drawn. Most people today don't even try to make it into a centaur. They turn it into a teapot. This is the base of the teapot. Let's get the name out of the way. This is the base. You get a spout right there, a lid right on top, and then on this side, you've got a little handle. It's like a teapot tip side. If we want to zoom in a little bit, it's easier to see, and I can actually get rid of all those other lines. Let's just put the teapot up there like that. The base, the spout, the lid, and the handle. I'm a little teapot, and they're pouring tea. Sometimes it looks like the Milky Way is coming out like steam out of the spout. So that's Sagittarius the teapot. And remember, it really doesn't matter how you draw it, it's that you know the right stars, because there are some really cool things you can see in Sagittarius the teapot. So far, we've just looked at a few constellations in Mars, but there are some other interesting things along the ecliptic. For example, right between Sagittarius, which is right here, and Scorpius, there's Shula, the tail of the scorpion, right there. So zoom back just a little bit so you can see them all. You might notice this little clump of stars right here. That's called Ptolemy's cluster. It's just below the ecliptic. You can see it with just your eyes as a fuzzy little patch. It's a beautiful sight in a pair of binoculars. So if you have some binoculars, go out, find the tip of the scorpion's tail, and halfway between that and the spout and the teapot, you're going to see Ptolemy's cluster. Named after Ptolemy, Greek lived over 2,000 years ago. He didn't have a telescope, but he could see that little clump of stars, and he wrote about it, so they named it after him. Now, Ptolemy's cluster is about 800 light years away, and there are about 80 stars in it, and they're relatively young stars. They're 200 million years old. Doesn't sound that young, does it? For a star, that's kind of like being a teenager. They're like teenage stars. They're hanging out together, and just like teenagers do, so do the teenage stars. Now, there's another cluster that's twice as far away, but has more stars. That's this little one right here. It looks smaller because it's twice as far away. This is the butterfly cluster. This one's 1,600 light years away versus 800 light years away. And this one has about 125 stars in it. And you can see that one with a pair of binoculars too. Not so well with just your eyes, because it just fuzzes out into, looks like a couple stars close together, as you can see here. But it's quite pretty with a pair of binoculars. So there are two open clusters, and open clusters are the types of clusters that usually have relatively young stars, only a few, maybe between 50 and 300 million years old. That's like being a teenager when you're a star. And those are two easy ones to find along the ecliptic. Now, if they're young stars, they weren't always there. What might have been there like 200 million years ago. Go up to the ecliptic, right above the cap of the tea kettle, and off to the west or to the right, you'll see this little red patch. That's the Lagoon Nebula. This is a place where stars are being born right now. Let's zoom in and take a look at it. It's very beautiful. When you look at it with your binoculars, you'll see all this detail. You'll see all these lines and things. You'll see all these young stars that are just formed from this cloud. You won't see any red color, though. That only comes with photography. You take pictures of it, it shows up really well. With your eyes alone, it's going to look kind of like a black and white picture. And this is a cloud of hydrogen, which is what stars are made of. And there's enough hydrogen in this cloud to make maybe 400 or 500 stars like our sun. So if you could come back in 100 to 200 million years, this cloud will be gone, and there'll be an open cluster of stars like Ptolemy's cluster or the butterfly cluster. This one's going to look bigger because it's a little bit closer to us. This is this one's actually further away than Ptolemy's cluster. It's 5 light years away. So it is further away, but it's really big. It's over 110 light years wide from side to side this way and 50 light years tall this way. So it's a really, really big cloud of gas. Beautiful thing to see and easy to find with your pair of binoculars or a backyard telescope. Now, there are two kinds of clusters. And what we've seen down here with Ptolemy's cluster and the butterfly cluster are open clusters of young stars. And we found the Lagoon Nebula where stars are being born. But there's a different kind of cluster, which is made of old stars, stars that might be billions of years old. And there's one right beside the tip of the tea kettle's cap, just to the left or the east of it. It's right in here. And this one is called M22. It's right there. Let's get it precise here, John. There we go. And this was very, very beautiful to look at. You kind of, let me stop time here for a second. There we go. This one's called the Crackerjack cluster. I guess someone looked like it spilled Cracker Jacks. I don't know how it got the name, but it's quite beautiful. It's called a globular cluster, and these are scattered around too. And globular clusters have a lot more stars than open clusters. Open clusters can have a couple hundred stars, maybe. This one has 500,000 stars in it. And some of the bigger globular clusters can have up to 1,000,000 stars in them. And the stars are really old. And these globular clusters halo our galaxy. We live in the Milky Way galaxy, and these kind of halo around the edge, and we find them around other galaxies as well. It's a beautiful thing to look at. You can see it easily with binoculars. You won't see all these individual stars with binoculars. It'll look like a fuzzy little patch. If you have a telescope, then you start to resolve the stars. It's an easy one to find, though, because it is right above the tea kettle's cap right here. Just find that cap star and look a little to the left. You'll find M22, the Crackerjack globular cluster. Go a little to the west and you're going to find the Lagoon Nebula. So Sagittarius has some little treasures hidden in it, and they're right along the ecliptic, the path of the sun. Well, let's keep following that ecliptic. If we head to the east, the next constellation we're going to come to is Capricornus. And Capricornus is the sea goat, whatever a sea goat is. I'm not quite sure. To me, Capricornus looks like a delta kite. We start with these two stars. You draw a line down to these two stars. Then you come up kind of this line of stars to this point, and then you come back again. It's just that little delta shape. Looks to me like a delta type kite that's diving bombing to the ground. They draw it a little differently, of course. I draw it down here, then I draw up, and I don't know exactly what the zigzag's supposed to be. And I don't know how you make it into a sea goat. I mean, we can draw some pictures on here if you want to see how they envision it. I guess it's half goat, half fish. It must be, I know some mythology, and I've never heard stories about the sea goat, but there must be stories about the sea goat. I should look that up. That's Capricornus. Now, there's nothing specific in Capricornus I'd like to show you, but there's something very nearby, and Capricornus is the easiest way to find this object, and that is the planet Saturn. So let's just dim down some stars here a little bit. I take that away because I find it can be, with all those stars, it can be kind of confusing to see these constellations sometimes. So see that delta shape? That's Capricornus. Go to this point, and just beyond it, you're going to see a slightly brighter star. It kind of stands out. That's actually the planet Saturn. Saturn's not in Capricornus, it's in Aquarius, the next constellation of the zodiac. And you notice that Saturn is just below the ecliptic. All the planets stay right along that line. Sometimes they're on it, sometimes they're a little above, and sometimes they're a little below. They're orbiting the sun, and their orbits can have a little tilt to them. So while it may be below now, at another time, in another point in its orbit, it might be a little bit above. Well, there it is right there. So let's check it out. Let's go in close and check out this planet. So far, we've seen Mars. Well, the next planet we have here is Saturn. And Saturn is my favorite one to look at with the telescope. And if you want to see Saturn's rings, you do need a telescope. If you look at it with binoculars, you might get a hint that it looks like an oval star versus a dot or a round planet. Like if you look at Jupiter or Mars, you'll get a round disk with binoculars. But this is slightly oval, and that's because of the rings. The planet itself is not oval, as you can see, it's round. Now, Saturn's 700 times bigger than the Earth. It's a huge planet. Not as big as Jupiter. We'll see Jupiter in a few minutes, but it's the second largest planet. It's made of clouds and gases with some metallic hydrogen inside, which is a type of liquidy substance. Nothing you could float a boat into. It just changes from these clouds and gases into this metallic hydrogen deep down inside. And then there may be a rocky core deep inside, but nothing you could ever get to land a spaceship on. So no one's going to land on Saturn. So what kids always ask me is, well, can we land on the rings? Well, the rings are made primarily of ice and mostly water ice, but it's not a sheet of ice like a frozen lake. It's more like crushed ice, like you put in a soft drink in the summertime, without the soft drink, of course. Some of the particles are no bigger than what you'd put in your soft drink in the summer. Some are the size of ice cubes. Some are the size of a house. Some of them might be as big as a half mile in diameter. Most of them are very tiny, smaller than your fist. As a matter of fact, the rings are from outside edge here to the inside edge about in here. That's a distance of about 30,000 miles. So it's an extensive set of particles. It's like an asteroid field of tiny ice particles orbiting Saturn. 30,000 miles wide, but if you measure their thickness from top to bottom, the thickest points, it can be up to a mile thick. If you averaged out the thickness, though, the average thickness is about 80 yards, a lot thinner than a mile. 80 yards, that's thinner than the length of a football field or a soccer field. So it's pretty amazing to think about something 30,000 miles wide that's skinnier than the length of a football field. That's just blows me away. Saturn, by the way, has more moons than any other planet. These dots around it are some of its moons. They look big here. If you look through a telescope, they're going to look like stars. They aren't going to look like big discs here. They've just made them discs in this program so they'll stand out so you can study them. You can see there's Tethys, and this one over here is Enceladus. Down here's Mimas and Dione and so forth. Well, when I said it has the most moons, right now we know of 146 moons going around Saturn. They aren't all big. A lot of them are very small. There's 17, 20 ones, and the rest of them are very tiny. But can you imagine 146 moons going around? Make a pretty busy sky, wouldn't it? Well, Saturn's something you really want to check out with your telescope if you happen to have one. When I do star parties, like if we were on Quill Hill tonight, I'll be showing you all Saturn. One of my favorite things to do is share Saturn with someone who's never seen it before, because it really is pretty spectacular. Now, we saw a nebula where stars are forming, the Lagoon Nebula. Well, down here in Aquarius, let's come down this end here. And Aquarius is the water bearer. So the way it's drawn, let's back off just a little bit here, is I imagine, let's get rid of the lines. I want to show you how I see it. Let's get rid of this line too, because that's confusing. So I draw a line between these two stars, and that is the man's body. He's lying down like on a couch or a bed. He doesn't feel so good. So actually, and I come all the way back, and these are his 2 feet. His body's here and his head's up here. And then down here, let me shut that planet off for a second. And bring the stars up a little bit. Oh, I shut them off. Bring the stars up a little bit brighter. So he's got 2 legs here, a body and a head. And then down here, there is supposed to be like a bucket, and he's pouring water into the bucket. So let's put the lines back up. It's easier to see outdoors than it is in here. So this is supposed to be his water bucket down here. And this is his body. And to me, it looks like someone laying on the couch who doesn't feel very good. And mom's put a bucket there just in case you lose it or something. I don't know. It's a very strange looking constellation. But I started going about this nebula. There's a nebula in here I'd really like you to see. It's one of my favorites. And this is not where stars are forming. This is where a star is dying. So you get down the bucket down here. That's this part right here. Go to that bright star, hop over to these two, and you get a little triangle. And just beyond the triangle, right here, is a little nebula called the Helix Nebula. And I'm going to see if I can center it here for us and zoom in on it. And this is what's called the Planetarium Nebula. Quite beautiful, isn't it? And when it's called the Planetarium Nebula, because when these were first found, and their planetary nebulas are scattered all over the sky, they have a round appearance, just like a planet has a round appearance. And when they first started discovering them, it was right around the time that William Herschel discovered the planet Uranus. And that made other people want to discover planets too. And they started seeing these round objects. Could that be a planet? And they realized it was not a planet, it was a nebula, but it was one that looked like a planet. So they call them planetary nebulae. They have nothing to do with planets. This is how medium-sized stars like our sun die. When our sun dies in about 5 billion years, so don't lose sleep over it, it's got a ways to go yet. But when it dies, the outer layer, it's not going to explode in a giant explosion. The outer layers are just going to get pushed away in a mild explosion, and they'll go drifting off in all directions. It's that outer layer drifting away from what was once a center star right in the middle here. And it's expanding outwards at about 1,000 miles an hour in all directions. So this one's called the Helix Nebula. It's about 520 light years away. And right now it's about 1.5 light years in diameter. Now, I've used the term light years quite a bit here. And if you don't know what a light year is, it's a length, it's not a length of time, it's a distance. Like an inch is a little distance, mile is a bigger distance. A light year is the distance a beam light will travel in a year's time. And light travels at the incredible speed of 186,000 miles per second. So in 1 second of light goes 186,000 miles. That's a long way. It's like going around the earth 7.5 times in 1 second. So if you go at that speed in a straight line for 1 year without stopping, the distance you cover would be 1 light year. This is 1.5 light years across. So it's pretty big, and it's expanding outward. So you can find that in Aquarius, the water bearer, one of the constellations of the zodiac, and you see it's just below the ecliptic path of the sun. So we've gone from our planets back up here. We've gone from Sagittarius to Capricornus, and we found Saturn by using Capricornus, because Capricornus actually, that delta shape stands out better than this weird looking guy with a bucket of water. And remember, though, that it's actually right now, if we put our boundaries up, you can see that Saturn is now in Aquarius, not in Capricornus anymore like it was last year. After we leave Aquarius, we come to Pisces, the fish. And we're going to go a little bit later in the evening now because we're getting down near the eastern horizon, and Pisces is partly below the horizon. So we got to go ahead in time. Right now, we're at about 7:15. So let's go ahead to about 9 o'clock or so. And we'll just keep going just a little bit more here. And we'll find another planet coming up. That bright object is Jupiter. But we got a few things to find first. Before we get to Jupiter, let's see Pisces the fish, which is right here. And Pisces the fish, there's two fish. There's a fish here and a fish over here, and a string going between them, like a fisherman's reeling him in. They've got a double line out and they caught a fish in each one, and the two lines are tied together right here. We can put up some pictures there if that would help you visualize this. Let's take the boundaries down for a minute. So we got Aquarius, the water bearer. They have him pouring the water. Many pictures show him lying down with a bucket of water, the way I described Aquarius. As you can see, pictures are easier to see than others. Sagittarius, the teapots, I think is pretty good. The scorpion is really good. Aquarius, it's a little challenging. And having two fish tied together with a string is like a little bizarre, if you ask me as well. But just beyond Pisces the fish, we get to a really major planet, and that is the planet Jupiter right here. There's Jupiter in Aries, the Ram. It's not in Pisces, it's in Aries. So let's take a look at Jupiter. We zoom in on Jupiter, and this is one with your binoculars. You can see Jupiter as a disk, and Jupiter has at least 95 moons going around it. But with our binoculars, if you can really steady yourself or a small telescope, you can see 4 of them. It has 4 large moons and then at least 91 other much smaller moons. Some suggest there may be as many as 125 moons going around Jupiter. NASA right now officially declares 95. That's still a lot of moons. Now, when you look at Jupiter, this planet's 1,000 times bigger than the Earth. So it's a huge planet. It's like Saturn. It has no ground. It cannot land here. And the winds blow through the clouds, stretching them in long bands. These brown bands go towards the west at about 100 miles an hour, this one and this one, while the white band in between them and the one down below go to the east at about 100 miles an hour. And sometimes you get little eddies swirling around, like the famous red spot, which you see right here in the center. It's actually not all that little. It turns into a giant hurricane. And while that looks small on Jupiter, that red spot is 2.5 to 3 times larger than the Earth. Just that spot gives you an idea of how big Jupiter is. Now, these moons look really big compared to the red spot. They're actually really small. If you looked at Jupiter, just like I said with Saturn, the moons are going to look like pinpoints, like bright stars next to Jupiter in a line. They make them bigger in this program just so you can study them better and not miss them. But tonight, if you were out looking, you'd see Jupiter and you'd see 3 moons to the west, 1, 2, 3, and 1 way over here to the east. Go out tomorrow night and they'll be in a different order. Sometimes you might see 2 on one side and 2 on the other. Sometimes all 4 are on the same side. Sometimes you only see 3 because 1 might be behind the planet, or it might be directly in front of the planet. And that can make it challenging to see as well. So it's kind of fun to look at Jupiter for several nights in a row, because those moons move back and forth pretty quickly. The bands, what you'll see is those 2 dark bands that look reddish colored here. Again, you're not going to see the color. And if the red spot's visible, you might see the red spot, but it won't look red. It's just going to all look like a grayscale image. Our eyes aren't very good at seeing faint color. They can see faint light. We have a type of receptor that's really good with faint light, but it's colorblind. So it looks like black and white pictures. And that's what Jupiter will look like and the nebulas look like. You don't see that color. That's unfortunate. If you take a photograph, then the color comes through. Cameras can detect the color when our eyes can't. So Jupiter is a pretty amazing planet. It's 1,000 times larger than the Earth. It's bigger than all the other planets in the solar system combined. So it's a huge planet. There's only one thing in the solar system bigger than Jupiter, and that's the sun. And the sun is 1,000 times larger than Jupiter, 1,000,000 times bigger than the Earth. So that's in Aries, the Ram, and it's usually just drawn as these stars right here. And I don't know how you make that into a ram. They put it kind of like as the spine of the ram in this drawing, but it's usually just drawn this way. And that's the ram. Now, we've looked at Mars and we've looked at Saturn and Jupiter, but there are 2 planets in this region that we've passed over that I want to take a deeper look at, and they're more challenging to find. Mars, you're not going to find because it's in the glare of the sun, but Saturn and Jupiter are going to be really easy to find. Once you find Jupiter, there's one not too far away that's not that hard to find. It's right along the ecliptic to the east, which is to the left. Come down the ecliptic, and you can see the Pleiades over here, the 7 sisters. That's not a planet. That's a cluster of stars, an open cluster like Ptolemy's cluster. This is probably the most famous open cluster. But about halfway between the 2, you're going to see a little faint bluish star. And it definitely, with binoculars, you will start to see a little hint of blue, perhaps. With the telescope, you can see the blue. And you can just see this with just your eyes. It doesn't look like a very bright star, but you can see it. And that's the planet Uranus right there. If you have a telescope, you might want to check it out. It'll look like a little blue dot. This is better than what you're going to see with your telescope, this view right here. And what you can see in this view, depending on how it shows up over Zoom, you can see these faint rings going around it. It has rings just like Saturn, but they go up and down because this planet is tipped over sideways. The North Pole's not on top like at Jupiter or Saturn, and South Pole's not at the bottom. They're on the sides. And scientists think millions of years ago, it was in a collision with something. Something hit it and knocked the whole system sideways. All the rings go around up and down as well. That means for half the orbit, the northern hemisphere faces the sun. For half the orbit would be daytime for the northern hemisphere, while the southern hemisphere would be dark. As they go around, then it swaps. Very strange day-night sequences here. Now, you can't land here either. This is what's known as an ice giant. Ice giants are sort of like gas giants. There's no ground here, but you're farther out. You go, remember the order of the planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus. And Uranus is twice as far from the sun as Saturn is. Saturn's 1 billion miles. Uranus is almost 2 billion miles. It's a long way out here, so it's cold. And lots of things crystallize into ices in the atmosphere of these worlds. So there's crystallized water, which we know is snow and ice. There's crystallized carbon dioxide, which we call dry ice, crystallized methane, all kinds of things crystallize and blow around in the atmosphere and sink down in, then sublimate, then go back up and crystallize again. And so there's lots of ices here. So it's an interesting world. That one you can just barely see with your eyes if you're in a nice dark spot like you would be if you're in the Rangeley Lakes area. The other ice giant, which is more challenging, is Neptune. And we passed by Neptune, but I'm going to zip back along the ecliptic and see if we can find it. It's a little more challenging. It's not too far from Saturn right now in the sky. To find it, I'm going to bring up the boundaries here. And it's actually in Pisces the fish. So here's Saturn over here. See Saturn right there in Aquarius. Right after you cross the boundary from Aquarius into Pisces, I believe it's that little dot, right? It's going to be right in that region right there. Let's see if I got it right. Am I right? No, that's not it. I've lost it. I thought I had it here. Oh, no, it's over here. It's down further. There it is right there. This one definitely has a bluish color, and that blue color does seem to come through a little bit. It'll look like a little faint blue star. And that's the planet Neptune. Even I have challenges finding these things sometimes. This one you will not see with your eyes at all. Even though it showed up on this program, outdoors you cannot see it. It's below the visibility of your unaided eye. With binoculars, if you know where to look, you might get a hint of a little faint bluish star in that part of the sky. It'll look better in a telescope. But even in a small telescope, it's going to look just like a little blue dot. You're not going to see any features on it to speak of. Here, this picture is made from satellite data, and you can see hints of the two rings going around it, the two major rings. You won't see those rings either, just like you won't see the rings of Uranus with a backyard telescope, even though they're there. They're too thin and too far away. And this one's another 1 billion miles further away than Uranus. But it's right there in the sky, just in Pisces, just to the east of Saturn. If we zoom way back, remember, here's Saturn over here. You go past all the way through Aquarius, and just after you enter Pisces the fish, it's just below the ecliptic, right about in there. All right, well, let's go up, stay up a little bit later. We found some interesting things in the sky, but if we want to see more and keep following the ecliptic, we got to stay up a little bit later. So I'm going to zoom way back so we can see how things are progressing here. And we're going to speed up time. And we're going to stay up to about midnight now. Let's go right up to midnight, which is right about now. And let's go just a little bit more because I want you to see the whole thing. This right there we go. We're just after midnight now, and you can look back where we've been looking, and you see all the way back to Saturn is still in the sky. Capricornus is about halfway below the horizon, and just that tip part sticking up. Aquarius is over here in the southwest now. High overhead, you have Pisces and Aries, and Jupiter's right up high in the sky. You can't miss it. The next zodiac constellation after Aries is Taurus the Bull. To see Taurus, remember, follow the ecliptic because the ecliptic goes through all these constellations. We have the bright star Aldebaran, which is the bull's eye. And just below it, you can see this V shape right here. That's the Hyades, which marks the bull's face. So this would be one of his eyes. This little triangle might be his nose, and maybe that's his other eye. Kids always want the bull to have two eyes. So we have one bright eye and one dim eye. Maybe he's been fighting, he's got a black eye, so one's not as bright as the other. Now, bulls have horns, so we've got a big horn coming up to this star, another big horn coming up to that star. Then the back, his back of his neck is this little line of stars, and his back comes up to the seven sisters, or the Pleiades here. And then he's got a front leg here and a front leg there, and his belly kind of comes up through the stars. There's no hind legs or a tail. It's just the bust of the bull. They draw him a little differently. They give him his two horns, but they leave out this other leg, which I think is too bad because it's pretty easy to see a second leg there. And they don't give him his belly. I would draw it differently, but you've heard me say that before. So that's the next constellation. There are no planets in Taurus right now, but there are a couple of interesting things like the seven sisters here. And if you have binoculars, you definitely want to check this out. With binoculars, it's really beautiful to look at. It looks like a little pile of diamonds in the sky. And this is one of the brightest open clusters we can see in the sky. It's 440 light years away. So as these things go, it's relatively close. And these are younger than the other clusters. These are only about 70 million years old. So these are kind of like maybe sixth graders, if you want to compare them to people. And they're all hanging out with their friends. Now, with the binoculars, it's going to kind of look like this. What's cool is if you take a photograph of them, they look like this, and you get to see some of the nebulosity that perhaps they form from. There's some argument that this nebulosity may not actually be part of the cluster. There's some evidence that it's actually closer than the stars. But we know that these stars did form from nebulae. If you've been around 100 million years ago, none of these stars would have existed. In its place would have been a nebula like the Lagoon Nebula, and that would have been really cool to see. Now, we have seen a couple different kinds of nebulas. We saw a hydrogen 2 gas cloud, which is what the lagoon is. That's where stars are forming, that red one we saw right off the bat. And that's where open clusters like this form. Then we saw the planetary nebula, the helix, which is where stars like our sun die. But big stars die differently. They die in giant explosions, and those explosions are called supernovae. On July 4th, 1054, about 950 years ago, suddenly, right above the left horn of the bull, right in here, a brand new star appeared in the sky. The Chinese wrote about it. They called it a guest star because it came, it stayed for 6 or 8 months, and then it faded away and disappeared. It was like a guest. It came, it stayed, and then went away. And they wrote that the star was so bright that you could go out at night and read by the light of this star. Can you imagine? It was no bigger than any other star, but it was way, way brighter. It was the brightest thing in the sky other than the sun and the moon. Well, today we can look at that spot and see what's left of this star that exploded 950 years ago. It's right in this region. Let me see if I can find it here. Sure, I've got it here. Where did you go? Oh, it's right in front of me. It's right here. And it's called the Crab Nebula today. And it looks like this. So this is a star that blew itself up. Only giant stars can do this. The star that blew up to make the star had to be at least 8 to 10 times more massive than the sun. Anything smaller than that will die and create something like the Helix Nebula. That's what our sun will do. But massive stars have so much more weight that they go through a whole different life cycle. The sun's turning hydrogen into helium. Eventually it'll turn helium into carbon, and then it won't do anything else. It'll shrink and form a planetary nebula. I'm simplifying the situation here a little bit, but that's essentially what they do. Giant stars, they make hydrogen into helium, then they make helium into carbon, and they make carbon into neon and all kinds of other things until they start making iron. And all those reactions give off lots of energy. That's what makes stars shine. But when you start making iron, it consumes energy and it doesn't give off energy. And then the star implodes, it collapses on itself. When it collapses, it creates one giant fusion reaction that creates everything heavier than iron. And the star blows itself to bits. And that's how everything denser than iron is created, like silver and gold and platinum. So if you have a gold ring on your finger, like I have my wedding band, or you have a silver earring in your ear, you should realize that that gold and silver you have on your body right now was created in an explosion like this. You have a piece of a supernova on your body right now. How cool is that? And we see when the spots where those things are made right there in Taurus, the bull, right between the bull's horns. I think that's pretty cool. So that's right along the ecliptic. And you see that Crab Nebula by that designated by that circle is just below the ecliptic of the sun, the path of the sun across the sky. Let's go a little bit further along. Let time go on because I got to keep you up till dawn, remember? So we're getting now to about 3 o'clock in the morning. Let's stop at 3 o'clock in the morning. And after Taurus comes the Gemini twins. Now, the Gemini twins don't have any planets in them, or there are some open clusters and things, but I'm just going to show you the Gemini twins because I think they're pretty handsome. And they actually, to me, look like what they're supposed to. Two stick people, two brothers named Pollux and Castor. This star's name is Pollux, and this star's name is Castor, and it marks their two heads. You got a stick body and a couple legs here for Pollux, and an arm, and he's holding hands with his brother. His Castor's head, he's got a longer neck and a longer body and shorter legs. So they're clearly not identical twins, fraternal twins, I guess. And you might notice they're standing on this fuzzy patch of light. That's the Milky Way. This is one of the spots where the Milky Way crosses the ecliptic. The other place it crosses is in Sagittarius, the teapot. It goes up high across the sky, then comes back down and crosses by Sagittarius, which is pretty much the opposite side of the sky from where we are right now. Well, let's keep going a little bit further. Oh, no, I don't want that. A little bit further to the east, and we come to Cancer the Crab. And Cancer the Crab tonight contains the moon. It won't tomorrow night, but it does right now. So let's take a look at the moon. That's part of our solar system. We saw that Saturn has 146 moons and Jupiter has at least 95. Uranus has 27 and Neptune has 14. Earth has 1. And this is our moon. Let's zoom in on it and take a peek because the moon's always fun to look at. And it's a great thing to explore with a pair of binoculars. Now, when you look at that moon, you can see some craters. This is a crater right here named Copernicus. Just below it right now, it looks below, sometimes it looks sideways, it depends the angle you're looking at, is a crater named Kepler. Craters were initially named after astronomers and philosophers. And generally speaking, I forget which way it goes, as you get older, further back in time, I think you go further south or vice versa, or further north. And so there's a chronology to the way they were named. And they were named by two people, Riccoli and Grimaldi, I believe. This one right here is named Grimaldi, pretty prominent one. And Riccoli is not too far away. I don't know that it might be in this view. I can't tell for sure. I don't know my craters as well as I know my stars. The interesting thing is they gave themselves nice bright craters, and they gave astronomers they liked, like Copernicus and Kepler, fairly prominent craters. But at the time, Galileo was not in favor, and Galileo got a little tiny crater way over here. Even though today Galileo is very famous, he got a very indistinguishable crater because he wasn't in favor with the astronomers of the day and the clergy of the day, really, as much as anything. So the story of how they got made, not how they got made, but how they got named is an interesting one. The dark regions that you can so clearly see here, those aren't craters. They're what we call the maria. Each one is a mare or a mare. I've heard it pronounced both ways by people who supposedly know. So I use them both. And those are actually hardened lava flows from volcanic eruptions or from craters that went so deep that they burst down through the magma. Then the magma came up and filled giant basins where there are impact basins. So these dark areas are lava flows. And this little one here is called the Sea of Moisture. This really big one is the Ocean of Storms. And this one here, which is partly a filled crater, is known as the Bay of Rainbows. So they got some really interesting names, and there's great stories about that too. Craters like these the craters are made by impacts from rocks from space hitting the moon and blasting big holes. And this one here, Copernicus, I don't know the exact diameter in miles, but my guess is it's probably pushing 100 miles in diameter, 80 to 100 miles. It's a pretty big hole in the ground. and the smaller ones obviously is smaller, and they're all over the place. The place you want to look to see them best is along the line between nighttime and daytime. That's called the terminator line, and that's where you'll see the most interesting things, because there's some shadows there, and the shadows create contrast and make them pop out. You look over here where you're not near that shadow line, and there are lots of craters in here you can't even see because the sun's filling them up and it kind of washes them out from our field of view. So definitely check out the moon. And if you're out tonight, if we'd been out tonight and we looked at the moon, if we stayed up late enough to see it, which we probably wouldn't have done, but right underneath it is this another little open cluster of stars. This one's called the Beehive, and it's right in the heart of Cancer the Crab. The crab is just these 4 squares. That's the crab's body, and he's got 2 legs on each side. Sometimes they draw this leg from this star. They just draw them differently than I would, and this leg over here. Now, if you know anything about crabs, you know they have more than 4 legs. They have 8 legs and 2 claws. In mythology, the crab got kicked by Hercules, and when he got kicked, some of his legs went flying. So the crab in the sky doesn't have all of his legs. The Beehive cluster is right in the heart of the crab, though, and it's one of my favorite ones to look at. If you do have binoculars, check it out. It's quite beautiful to look at. And there are a couple of stars that stand out. There's a couple that have a reddish orange color. And with individual stars, sometimes you can see that color, whereas with nebulas and planets, they don't show up very well. So it's just a beautiful little group of stars. It's about 570 light years away, and maybe a little bit older than the Pleiades, 600 million years old. And there are over 1,000 stars in this cluster. It's farther away, though, so it doesn't show up quite so bright. Let's zoom back. Well, we still have 2 more planets to find, and they're going to come up just before the sun. We see one of them right here, and that's the planet Venus. Venus is in the next zodiac constellation called Leo the Lion. Let's bring Leo up so we can see all of the lion if we can before the sun comes up. Right there. So to see Leo, this half curve is the mane on the back of the lion's head, and just draw a whole circle here, and that's the lion's head. His face is over here where there aren't any stars. You have to pretend that part. This big rectangle is his body, with Regulus, the bright star next to Venus, is his heart. Let's just take the planet down for a second. You got a leg here and another leg here. Come back his belly, and there's a faint leg coming down to this star and another one coming over to this star right by the ecliptic right there. Those are his hind legs. And then his tail is the star here named Denobla, which is Arabic, which means tail. So that's Leo the lion. And I like Leo. I think it actually kind of looks like a lion. If we put the drawing up there, you can kind of see how it all fits together. And to me, this one kind of fits better. And the scorpion and the Cancer of the Crab, given that he's lost a few legs, you can kind of imagine that too. Now, kids say he needs a bright star, but when you think about crabs, they like to hide because things like to eat crabs, so they don't want to stand out. So to me, it's appropriate that Cancer doesn't have any bright stars, so he can hide in the sky and not be scooped up by a seagull or something. And as we look back to Gemini, I think the Gemini twins look pretty good, and even Taurus the bull's not too bad. Then you get back to, Aries the ram, and Pisces the fish, and Aquarius the water bearer, and those ones are a little bit more challenging. So as you move to the early morning, we get to see a few more interesting constellations that, to me, actually look more like what they're supposed to. Well, let's check out Venus while we're right here. Venus is right by the heart of the Scorpion. And if you look at Venus with a telescope, maybe even with a good pair of binoculars, you'll notice it looks like a half a moon. Sometimes it looks like a crescent, and sometimes it's kind of a gibbous moon, which means it's more egg-shaped. You never see it around full Venus because Venus is between us and the sun. And so to see a fully lit planet, you've got to be between the planet and the sun, and Earth doesn't ever go there, and you probably don't want to. It's going to get warm as you get that close to the sun. So we see half the sunlit side and half the nighttime side. And you're not seeing any ground here. Venus has ground. You could land there if you wanted to. I don't think you'd really want to because Venus is covered with clouds. Let me stop that motion so it doesn't drift away on us. And it's totally engulfed in clouds. So if you lived on Venus, you'd never have a sunny day and you would never see the stars at night. That turns me off big time because I like stars at night, obviously. And I kind of like sunny days too. But even if you don't mind the cloudiness, you still wouldn't like it because the clouds hold in the heat, making the surface temperature 900 degrees Fahrenheit day and night. holds the heat in like a blanket. The air is carbon dioxide and it's poisonous to us. And the clouds are made of sulfuric acid. And it has 90 times more air than the Earth does, which would be like being on the bottom of the ocean. The weight of the air would crush you on the ground. This is not a very friendly planet. Quite beautiful to look at, though, if you look at it in the night sky. So it just looks like a bright star. It'll look like the brightest star in the sky. It won't be quite as bright as the moon, but you really won't be able to miss it. So let's let things keep progressing here. Oh, we want the atmosphere back up because we're almost to sunrise here. If we speed up time a little bit and let it keep moving, we'll find the sky starts to lighten up here very quickly. And just before the sun comes up, oh, I stopped it just a little soon, our final planet's going to come up. And you can see it just to the right of the east mark here. That's the planet Mercury. Now you can see the sky is getting light, and Mercury can be a challenge to find. You can find it with binoculars or a telescope. It's just going to look like a dot. You're not going to see any features on it at all. It's the smallest planet, and it's very close to the sun. So once the sun comes up, don't look for it because you're going to be too close to the sun. And if you, by accident, you take your binoculars or telescope and look at the sun, you can permanently damage your eyes by pointing it at the sun and looking directly at it, even for a fraction of a second. So you want to look for Venus, for Mercury, just before the sun comes up. Once that sun cracks the horizon, it's going to disappear, so you won't find it anyway. And if you do happen to look towards that sun, you are going to damage your eyes if you look at it through any type of optics. You see how it's fading away? All the stars are fading away. Draw the lines away, and we are right back. And there comes the sun back up. We're at sunrise tomorrow morning. And remember, if we look at the constellations behind the sun, what's going to be back there? Virgo the maiden. And it's right beside Leo the lion. See, Leo's still up there in the daytime, and so is Cancer, and so are the Gemini twins. But you can't see them because of the glare of the sun. You can find Venus, though. I've got a good friend, and he can find Venus in the middle of the day. It's in the sky, and if you know where to look, you can find it with a pair of binoculars or a telescope. I'm not so good at that, but my friend Larry is very, very good. So we've just gone all the way around the zodiac and used that to look at the stars. And there was my friend Larry. He's on here tonight. I'm glad he's here. And I hope you've enjoyed a kind of a different look at the night sky. Did Larry want to say something? Is that possible? I hear him waving his hand there.
I'm happy to join this great display of planetary power, and I'm a friend of Venus, and I encourage your own friendship with the friendly planets and stars that were so eloquently displayed by my colleague, John Meter. Thank you.
Thanks, Larry. It's nice to have you here tonight. I'm glad you're able to join us and take a tour of the ecliptic path of the sun across the sky, which is right there from sunset to sunrise. I want to thank you all for joining us this evening, and hopefully in January, I think our next star party will be in January.